All right. And for the last of our plenary speakers, we have, next up is Dr. Bence Mátyás. Oh yeah, I was close on that one. Who is the founder and CEO of Genesis SFL, Hungary's leading space transportation service and LEO research provider. With a PhD in environmental engineering focused on soil microbiology, he drives innovation in space technology and agricultural research through products like GenoPlant portable labs and the MayaSat-1 biological incubator CubeSat. A blockchain developer and community builder, Dr. Mátyás gained widespread recognition for his Genesis 111 Mars terraforming mission, securing $2 million of investment on Shark Tank Hungary. That's pretty cool. His company partners with global organizations to offer affordable space research rights or services, specializing in small payloads. Everybody welcome Dr. Mátyás.
Is there life on Mars?
Yes.
Yes, I ask you a simpler question. Is there any traces of life on Mars?
Yes.
Probably.
Yeah, sure.
Sure, there's technical signatures.
So the thing is I'm trying to point out here is since 70s, right, the end of 60s, when the first Viking 1 and the Viking 2 landers arrived to Mars. Since then, we are interpreting images, right? And we are trying to conclude many smart things about the origins and about any other things. So that was 8 + 1 landers and numerous orbiters around the Mars since 72. But nobody can tell for sure is there any organic molecule on the surface of the red planet, which is, it's a little bit worrying, I think, because we are building up these expensive cameras, basically, sensors, sending there, and we cannot really answer these easy questions. What we can know is what we can detect from different asteroids and meteorites, which is coming from the Mars to Earth, and we can examine it in different to do that, we also want to use different plants and woody plants as a host organism because we want to use the growth of the root to regulate for continuously providing the microbes to the regolith. What is the reason? I'm a soil microbiologist, and I realized that most of the greenhouse gases production is happening in the agriculture, especially in under anaerobic conditions. I was comparing Japanese fields, paddy fields, compared to Hungarian lands, which are more ventilated. And we realized that the highest production of CO2, methane, and most of the nitrous oxides are happening underground. So it's a very good sign for us when we are talking about the Mars terraforming. So in this concept model, we are using 300 rocket capsules, which are planned to nurse the plants during the long 6 or 7 or 8 months travel. In meanwhile, the nose of this capsule is functioning also as a drill bit. I know that this hard impact, what you will see here, it's very hard to imagine, like mechanically, it's still challenging. We already conducted a couple of drop tests from Earth, from 2,000, 2,500 kilometer altitude, and we were testing not only in wind tunnels, the flight of the capsules, but also on the impact. Only in one case, the drill bit survived the impact. So it's one of the most challenging part. But in order to we can transport anything like more complex living organisms in such a closed ecosystem from one planet to another, for sure we are going to need portable laboratories. And this is the point I feel it very important to highlight, that the reason is we cannot detect, or we couldn't really have any real conclusion about the organic detection on Mars, is the overthinking and the fear of the back contamination. So the Viking 1 and the Viking 2 landers, it's understable, because compared to the 60s technology, they were also testing all of the parts from the rover for 5 years before they can actually put together. So it's a very old technology. We cannot blame on that. Even after that, that was a very big question in the scientific community after the Viking 2. So they tried to replicate the same measurements on Earth, and they failed. So we cannot really use this data. But it's happened with the Curiosity. It's very interesting because now the NASA and also the European Space Agency, in a joint collaboration, they build up the SEM laboratory. I don't know if you heard about it, but it's a very complex laboratory, including spectrophotometry, gas, and also liquid separation. But the main point is, because of the NASA high standard of the sterilization, we cannot use this data either, right? They are modern. The laboratory that they are using is state-of-the-art, but we cannot use it because until now we are still detecting the different reagents which are used for sterilizing the laboratory equipment. So because of that, even though we are detecting some sugars or whatever easy form of organics, we cannot really rely on them. So in this concept, we plan to transport plants as a host organism with a lot of microbes inside this capsule and penetrate the regolith. To do so, we carried out different tests in small-scale environment, and we tried to mimic the topsoil of the Mars. But it's really hard. As you could see, the ice sheet of the Martian soil layers varies between the poles to the equator, and the reddish color which you see on the Mars, it's just the upper layer, and we all know it's a kind of result of oxidization, but it's not really that. Because of the high radiation, the minerals and the rocks are releasing chemicals, peroxides, and many things. So that's why all of this degradation is more accelerated. But if you are going to the downer layer, and we know that because of the drill, the little holes that the preservants drilled, that the color of the soil is changing already upon a couple of centimeters under the surface. So the reason of the dimensions of the rocket capsule prototypes, it's because of the profile of the Martian soil, and including the ice sheet, which is like hiding underground. So we have to reach these layers if we want to keep the gas on the soil. Why it's important? It's important because of the molecular weight of the different gases. When we are talking about greenhouse gases production, we are basically referring three big categories, right? One is the carbon dioxide, which we all know because of the molecular weight is going to the downer layers. That's why the concentration is always higher in the downer layers on the soil than in the atmosphere, and it's the same on the Mars. The other is the methane. The methane is like a very light gas, so it's going to escape when it has a chance. It's going always for the upper layer. And the same is true for the nitrous oxides as well. So we started to validate our concept in small-scale prototypes, and obviously in laboratory conditions. And we built up different soil sensors and different plant laboratories. It's very important to highlight they are laboratories and not a sensorial approach. And in a very small environment, I'm talking about 0.5 liter oxytop bottles in a high number of repetition, we could mimic the topsoil of the Martian regolith and also the atmosphere. And we made two different runs. One, we are using the Earth-based atmosphere, and the other experiment series, we were using the Martian atmosphere pressure and gas composition. But we realized, upon 2 weeks, the microbes that we were applying, they were anaerobic microbes, also some viruses, but most of them bacillus strains. I will show you what we found out. So after the 2nd week, we fill up the oxytop bottles by the injection of 1 microliter of mix of different microbes. And it's a very important number because we can use this to estimate how many rocket capsules we need to make a very, very thin atmosphere, at least on the ground level for the Mars. So that's why that was important to us. Also, we were testing the flight test and the aerodynamics of these capsules before we started to build up the real-size prototypes. And we learned many important things, for example, on the hard impact and things which we have to improve in the future. So these are our terraforming microbes candidates, what we can propose for Mars. And I disagree with most of the scientists who share that we need to modify genes for terraforming Mars. We don't have to, at least not on the lower eukaryotes level. Maybe in human DNA we can, think or consider some different alteration, but it's happening in the nature either way, okay? Especially in the lower organisms. In the case of microbes, in a couple of days or in a couple of weeks, we can talk about different generations of microbes already who are mutating, who are, they have some changes in the genomic level already. So here are our candidates for Mars terraforming who were living in a Martian environment for 2 weeks, and they not only survive, but they produce CO2 up to filling up half a liter of Martian reality. How many of these rocket capsules will need to create the first 15-centimeter thin layer of the Mars? And it's not that shocking. As you could see, according to our estimation, we are going to need 2,000 cubic meter of space to fill up exclusively with CO2. In this case, we can ensure this very thin but stable layer in the ground level. Why we are thinking about to releasing the gases on the soil poles? The reason is very easy, because we can capture them and accumulate the molecules for a longer time. And it's about one physical attribute of the soil, and this is the clay content. Higher the clay content in the soil and deeper you go, the isolation is greater. We could observe it in Mars, we could observe it on Earth. It's like a general pattern. So 2,000 cubic kilometer, I also expressed in your unit. I'm sorry, I cannot count in that just in kilometers. So you can imagine it as the half of the Grand Canyon. We have to fill up with the gases, okay? Or in dimensions like the Mount Everest, we have to fill up the mass, the volume of the Mount Everest with gases. And if we do that, we cover the entire Martian surface by 15 centimeters of CO2 molecules. And if we do it on the ground, we have a higher chance to capture this CO2, because what is happening on the Mars? There are 4 seasons changing, right? And in the winter, it can be so cold that the atmosphere is escaping for 2 different reasons, but one of the reasons is the atmosphere is freezing out. The CO2 is freezing out from the atmosphere. So when we see these big surfaces of ice on Mars, is just a smaller part is waterized, but the majority is CO2 ice. Okay, so that's why we know that there was obviously, and there gases which are being reproduced by, we don't know by what, maybe microbiological processes already, but maybe can be, just because of the minerals activity. So the main point is, according to our estimation, we need 40 years if we launch every 4th year a Starship with 300 rocket capsules in it. So we need only 1 spacecraft per mission. And so every 4th year, we are injecting 300 capsules. And for 1 capsule, we need only 1.2 liter of microbes, okay, to inject this area. One of the most difficult part for us was also funding the funding. So this is the funding of the first layer of the Martian atmosphere, let's say. We applied for the European Space Agency Business Incubation Program. And the first time we were rejected because the Mars terraforming concept was part of my tender, okay? So the ESA is basically following the NASA protocol. But my question is, we are so afraid of this back contamination. Roscosmos applied the same sterilization protocol like NASA. You know what I'm trying to say? The Chinese, India, using the same protocol? I don't think so. I think we already bring many microbes to Mars already. So, and vice versa. So this is the politics, I understand, but you know, it's slow down many processes. So after half year, I tried again for apply for this 50 grant. It's 50K grant, you know, and they said, please erase the Mars terraforming part and your tender will be okay. And that was so. So we gained the tender and we could finalize the development of the genoplant laboratories, because we realized that nobody will finance these kind of long-term missions, at least not in our environment. We are coming from Slovenia and Hungary, in which, you know, we just joined to the European Space Agency in the recent years. So basically, we are getting funds from downstream space utilization, but not for upstream. And even as though upstream, we cannot mention the Mars terraforming topic because nobody will support us. But we knew that if we are finalizing our portable laboratories, we can use it also in our rocket capsules, because the plants will need health monitoring during the long travel. I tell you what is the catchy point is the biomarker discovery, but our time is limited now, so I'm going to proceed. From a private laboratory, we gained 150K euro for biomarker discovery, because I knew that it will be a very interesting point, because the pharma companies are, you know, sponsoring the ISS research because of the hope of the biomarker discovery. But it's a little bit different in the case of the plants, and I will understand, and I will explain you why. So because of from the public sector, we couldn't get enough funding. We had to open for the private sector, and we were a small company, so we couldn't like release public shares immediately. But we modeled the shareholding system on a blockchain, and we deployed the Genesis 111 utility token, which you know, many people were smiling because, you know, they were having the idea it will be the same like, you know, those to the moon and things like this. But it's a serious token, because at the time when we are selling one of our laboratories, we are also distributing back the money for our early investors. So I wanted to say thank you for everybody who supported the blockchain activity. And within 3 months, it seems to be a good decision, because we reached a 2 million market capitalization on the blockchain. It's very nice and very nice numbers, but you should understand that we cannot use this money really. It's part of our marketing. You know, we have 1,000 investors from all around the world who put together like 150K, and now we are growing big. But why we are doing it? Most probably we won't, you know, plant trees, cut trees to print money on Mars. So we are not, most probably we are going to use a blockchain technology. This is part of my study, how a microeconomy react to different things, different facts, and it's very interesting to follow up. We also, on paper, we got 2 million from the Shark Tanks, from the before mentioned Shark Tanks, which until now we didn't receive. So they stated on the Forbes, they stated the sharks on almost the mainstream that they, in past tense, they invested in this Mars terraforming. But I can tell you, I checked my account in the morning and the money didn't arrive yet. So we were, you know, taking care of our own community, and we started to pay back the investments to them already. In the first year, we paid back 30K already from the 150. Other big and strong pillar for that kind of research is the biomarker discovery. If you are interested also the scientific outcomes of our research, you can check one of the electrophoresis or the renewable and sustainable energy, but I can tell you in summary what is the main point. We discovered 3 different biomarkers to early detect nitrogen, phosphor, and microelements in tomato and in other crops before their visual symptoms appear. I repeat, before its visual symptoms appear. What does it mean? When you see the leaf, it's getting yellowish, it's already late. When you detect from any sensors changing in the chlorophyll, it's already late. So we have to know what the signals of the stress for different biotic and abiotic factors on the plant if we want to, you know, apply fertilization. And that's why we can sell these laboratories also among farmers, and that's how we are making money, and that's how we are sponsoring our own research, because from the biomarker discovery, it's not happening in like a human medicine case. You should know about the GlycoStore. It's a human database in which they store correlation of different glycanic structures to predict diabetes 2 and cancer. And it's a very smart thing, because if they discover a biomarker, the market price will be determined according to how many people have this sickness and how the government can save money on treating those people, right? But in the plant biology case, it's not that profitable. Who will give me any money because of my 3 biomarkers? You know, I know the plant will have a nitrogen deficiency sooner than anybody else. But you know that nobody cares. Nobody really cares. Okay, so what was most important to us is push on the market the GenoPlant analyzer. So the last year, October 2023, was a very big milestone in our company, because since then we have a boxed product. So from a research group, we transformed our team to a company, and we started to distribute these laboratories. It's a B2B approach. It's for businesses. It started at 28,000 euro per unit, but basically bigger farmers are using it, and it's still very cheap compared to the traditional methods like HPLC. What is the main difference? In the HPLC and traditional analytical tools, they are using pumps and many other sensitive assets to perform complex analysis. In this system, we are not using any moving part. So we are applying high voltage for separate the molecules and ions according to their charge and size in liquids in record time, under 2 minutes. So also, we made 2 million market capitalization on the blockchain, which means that we sold 10 laboratory devices, and we also had some pre-sale in the end. So what is happening now? We are turning out from the laboratory to low Earth orbit. This is the first time when we can examine microbes, plants, yeast, human DNA in an orbit than never before. And this provided us an excellent opportunity to continue this Mars terraforming research, because the plants and the microbes that we selected in the laboratory, now we have the chance to bring it up to Earth low orbit. And a couple of days ago, it became official. So our company, the Genesis, actually is having now the last slots for the exploration company mid-size demonstrator space flight. This is the NIX. I don't know if you heard about it. It's a European company. They are also supported by the European Space Agency. It's a German and French-based company. So there are many people who joined us already. For example, Máté Fejt is a wind tunnel European and world champion, and he's going to send his DNA in our biological incubator CubeSat, and we are going to examine the changes on the genomes. Before the flight, we are going to run a PCR. After the flight, we are going to run a PCR. And the thing is, we are not only interested in the differences of the degradation of the helix, but we are trying to attempt to observe the rebuilding processes, the bridges, and so on. So it's a very interesting thing in the modern medicine, because there are gene banks who are storing the sport people DNA and different genomes for a longer term, preparing for another COVID or another big catastrophe, because their body, their system is resistant. So this is our biological incubator. It's not a render. This is the actual concept. We are using 2 main boards, one inside and one for outside measurement. In one main board, we can connect 6 different sensors to measure, basic parameters, also in the space environment and also inside the CubeSat. It's connected to a programming chip, and on the left side, you can see a ground gateway. And this is the actual concept. We are programming it in Python. And for that demonstration purpose, we just keep a small plant inside the cabin. But actually, for our 2025 mission, we are bringing up 980 different biological samples, including human DNA, plant, yeast, lower eukaryotes, including algae. And the main point is, it's a 3 orbital space mission. So we are going to polar orbit, which is it's not common. And I think astronauts were not in polar orbit yet, not human DNA and not any other biological samples. Correct me if I'm wrong, but I want to believe that this is the first one. These are our partner, the exploration company. This is the mid-size spacecraft, which called Mission Possible, and we joined to that spacecraft now. They have the first re-entry test this year, 1 month ago, and this is what's going to happen is 2025, February, between February and July, most likely. This is the 300 kilogram payload capacity cabin. And this is also a part of a test, because in 2027, the company is going to continue building up even a huger spacecraft to carrying up to 3 tons to International Space Station and other space station on low Earth orbit. So I hope that there will be more students present here. So let me to I wanted to give 15 places to set up 3 different biological research for the Mars Society and also for the students who are part of this work. So I would like to ask you later to, we can arrange it. In this CubeSat, we can fill up 5 different racks and hosting altogether 980 biological samples. A part of the DNA, we are going to also examine different plants, seeds, yeast, as well as root growing algae in a form of lyophilization version. So we are going to regrow the algae after the space travel. And the application deadline is 31st of August, the end of this month. So if you have students who are interested in sending up biological samples with us, this is the deadline, because after that, we are going to close the biological capsule and going to be prepared for a California launch between 2025, February and July. And after orbiting 3 times around an altitude of 800 kilometers, so it's almost the double height of the International Space Station, and we are also crossing charge zones 6 times in the poles, right? That's why because of the gravity of the Earth, there are many charged particles. That's why we can see the Nordic lights, right? So we are going to cross these zones 6 times, and it's provide us an excellent opportunity to measure the space effects on biological samples, and we can mimic the longer space travels in the term of the radiation doses and the other particles which we are going to cross. So thank you very much for your attention. It's a very good question, and I think we should have an answer from the JPL and an exact answer. But I heard about this study. They still cannot decide that forms of organics was produced by exclusively chemical processes or that was some biology behind. So if we can answer these questions and we can be sure after, I think we can be more brave when we are talking about, injecting especially. But when we are talking about manned missions to Mars, within a decade, when we are going to print and going to make constructions, obviously we are going to contaminate each other planets. So if we are doing it for real, and I want to apply like the same in the agriculture field, it's just a big, I consider it as a big field. So if we bio-inject in a correct way, we also can benefit. And, for the human colonies, it will be at least the first layer of atmosphere, even if in a ground layer, because it's going to happen anyways. So I just trying to, save time.
So we've reached the closing. And so last night, during my remarks at the banquet, I mentioned some of the initiatives that we're going to be doing during the coming year. We're of course, going to be continuing all of our existing initiatives, the operation of the Mars Desert Research Station, the Flashline Arctic Station, the rover contests, the education program involving engineering design contests for high school students. And then we're going to be launching a political initiative to have Congress demand that NASA present it with a plan to get humans to Mars in 10 years so that the discussion of the possibility of this can be opened. Okay. We're also going to be doing one more initiative that I failed to mention last night because there was so much going on and I didn't get to mention it, but I'll mention it now. then this is a Mars Technology Institute initiative. What we're going to do, I mean, look, there's a number of key technologies needed to settle Mars. And one of them is in the area of food production. Mars is going to have much more limited acreage, if you will, than is possible for agriculture on Earth. And they'll have to either be doing their farming in greenhouses or in tunnels that are lit artificially, and either one of those is going to be terribly constraining. And while it's certainly possible to do human Mars expeditions without any new food technology, an expedition can just bring its food, and a small Mars base could be supported by a greenhouse. But if we're ever going to have cities on Mars, and I mean even small cities like 10,000 people, 30,000 people, we're going to need to have a new food production technology that can produce food at least an order of magnitude, if not 2 orders of magnitude, more efficiently from an energetic point of view than how it is done in conventional agriculture on Earth. Okay. Now, there's a variety of such processes that people have discussed, including using bacteria to transform methane into protein, and then either using that directly or feeding it, for instance, to fish in an agriculture type setup, or using yeast to transform methanol into protein, which is in fact directly edible, or once again, feeding it to fish or livestock and creating a more attractive form of food. Okay, but we need to advance on these things. We need to have processes that can do it more productively than the current state of the art, that can produce more attractive forms of food, that can integrate it better with such things as aquaculture systems and so forth. So what we're going to be doing is we're holding a contest. It's an international contest, and there's going to be 3 divisions in this contest, okay? There's going to be an open section, which is open to anyone, including companies, okay? There's going to be a university section, okay, which is for university students or professors at either graduate or undergraduate level. And then there's going to be for students because frankly, there are high schools that have reasonably well-equipped laboratories that can do experiments of this kind. And we're going to want, you might call this a grand international science fair, if you wish. We want people to demonstrate processes that can contribute to this goal. And the thing about this is the following. Okay. Number 1, this technology is needed to settle Mars. Number 2, okay, the winners, okay, a condition of entering this is that they given the Mars Society an opportunity to patent the process that they invent. And if we do patent it, okay, they will get a quarter of what we get if we license the patent, or a quarter of the equity of this, of the Mars Society's share of any spin-off company that is created around this technology. And of course, they'll have the name on their patent, okay? And of course, there'll be prize monies as well. So we intend to create companies that will commercialize this process and make money that will help fund further research by the Mars Technology Institute, okay? And then finally, you see, there is a slander that has been used historically against the space advocate community, is that we don't care about the conditions of poor people on Earth. We're just all up in space. Well, there's nothing, absolutely nothing that anyone could do that could do more to better the condition of the world's poor than develop technology that can produce high quality food cheaper, okay? That is the most profound contribution you could make to the condition of the world's poor. And we're going to show that by addressing the problems of the human settlement of space, we're going to make a major contribution to that, okay? So that's something we're going to be doing. There'll be more details on this coming out. The Mars Society will produce a press release. We'll probably produce a video that will be posted in which this is explained in greater detail. The contest rules will be stated, etc. The prize is listed, all that kind of thing. And we're going to be looking for corporate sponsors for this, so we can actually hopefully well, increase the value of the prizes. Because by having a student section for this prize, I believe we're going to be doing a major contribution to STEM education in the biotech area. And biotech is an extremely important area for advancing technology in the 21st century. It's a revolutionary area, and we're going to be helping to get young people to actually exercise their talent in it, and perhaps get some to make that their careers. So that's another thing we're going to be doing. Okay, so, and they'll probably be doing some more things beyond all that, who knows? Okay, but anyway, I think it's going to be an exciting year, and we look forward to seeing you all again next year. And by the way, with this contest, I should say, the finalists for this contest will face off at next year's convention. Okay, so you'll get to see the finalists present their stuff and see how it comes out. It should be quite exciting. So on to Mars.